I have a battery isolation switch on the Daimler. With it being a soft top car, it makes sense to be able to isolate the battery, because obviously somebody could turn on the headlights, for instance, and flatten the battery while it's sat parked perhaps somewhere with the roof off. Anyway, so I had this isolation switch. It's only a cheap one I got probably about 30 years ago, and it's been fine all those years until recently, when it started to stick. It was sticking on and just wouldn't release to turn off or disconnect the battery. So I'm wondering why, and I've managed to take it to bits. And this is the base of the unit, and it's pretty simple. It's just a plastic moulding with these copper bolts through each side, and then on the top is like so, and has the big red key, which I've thrown that away. Anyway, the red key that fits into the end here, so it's a bayonet type arrangement, so that it pushes down this bridging piece, which again is a copper plate here in effect, which just shorts out these two bolts. So it looks as if this little steel plate here, a pointer, there's a piece of steel here which rotates. I think this entire pin looks to be plastic, and it comes through this little clip here on this side. Yeah, and that just pushes through. I wonder if that is plastic. It doesn't seem plausible, but it is plastic. Yeah. Okay, so there's actually two springs. Which is interesting. There's a small spring up against the pin, and then a larger one on the outside. I wonder why they would use two pins. One answer is just to give it more spring pressure, but it's an expensive way of doing it for such a relatively cheap switch. Anyway, it looks as if there's a recess here that's in the moulding with these two half circles, which is where this steel plate fits, and then the copper bridging piece can be pressed down to make the contact. So again, I'm not entirely sure why they'd have this steel piece here. Or is it just to ensure that it remains aligned? So I say a pretty simple mechanism, but it seemed to be sticking in this upper part, the head of this pin seemed to be sticking in here. In fact, it's sticking now. So what was happening was that the switch would turn on. You put the key in, and this would get pushed down and make contact to short out the two terminals. But when you take the key out, it wasn't sliding back up the shaft, because this is sticking in this cylindrical section here. I don't know why that should suddenly start sticking after, say, 30 odd years. If anything, you think it would get looser, wouldn't you? It would wear away and to get looser, but for some reason it's got stiffer. And that looks fine. No sign of any grit in it or anything of that sort. So it's rather curious. Let's have a look at this bore a bit more closely. I can't see anything in the bore that's going to cause it to stick. That's very weird. That looks perfect. Smooth, cylindrical, no dirt of any sort. That's very weird. Distinct resistance there. It's almost as if it resists just as the head goes in. It resists there and then goes free again. So about, I don't know, 5mm away from this base area, it seems as if the diameter has got smaller, which is very strange. That's kind of roughly halfway between the top surface as you're looking at it now and the first sign of the bayonet arrangement inside the cylinder. So that's kind of weird. Why would that have collapsed? It's as if this area here has become smaller somehow. I suppose the other thing to do is just take this clip off briefly or quickly. There we go. Not too bad. So there's the copper bridge piece, the steel guide, I guess, the big spring, and the smaller spring. Again, why two springs? Very odd. Actually, think about it, one spring goes inside that steel piece and the other doesn't. So what does that mean? I suppose it means that the, maybe that's the answer. Yeah, so that goes like that. So only one spring, so only this spring is actually pressing on the bridge piece to close the contact. So that spring, which is relatively stiff, yeah, I'd say the smaller one is stiffer than the outer one. So yeah, so this one is providing the load to close the contacts, whereas this one isn't participating in that at all. It's simply between this bridge piece, which goes here, and the top of the pin. There's the pin, as it is plastic, so there's no steel in it at all. Just clean it up a bit. And so this should be a nice sliding fit in here, and it isn't. It's quite stiff there. It's loose, no problem. Goes stiff about there, and then goes loose again at that end. So yeah, for some reason, I wonder if this can't have got hot, I don't think, and deformed the plastic. So this looks like it might be a thermoset anyway. That's very strange. I just can't think why that would have changed diameter. Either the pin doesn't seem to, in that the pin fits fine at this end and the far end. I don't think that's the where the problem lies. I think it must be this ball. I guess I might as well rub this out with a bit of emery cloth or something and get it back together working, because it looks like there's nothing wrong with it apart from that bore being a bit stiff. The contacts themselves are perfect. There's no obviously no arcing or anything of that sort being happening. So yeah, it's simply a question of getting this sliding smoothly, put it back together and it'll be fine. Okay, so I've managed to ease out this bore using an old punch and a bit of aluminium oxide paper, and now this pin does seem to fit into the bore freely. So I still don't know why it stuck, but anyway, it's free now. So it's a question now of remembering how on earth it went. So should push the spring back. That's better. So it's easier to get the clip on now because this bridging piece holds the spring back. There we go. Good, that's better. And now that will press that down. Yes, I think the answer is that this larger spring controls the resistance that the key feels and returns the whole bridging part up to its off position. But the inner spring, which is slightly stiffer, controls the force that's applied to the contacts. So there is sense in having the two springs. There's an initial relatively light force to get it closed at all, and then as the key goes fully home, it uses the second spring to apply a higher load just to keep the contacts close together. Okay, so far so good. All I will do next is to put some Vaseline on. I think getting some in the bore here is not a bad idea. It's because the danger with this sort of thing is that you attract dust and grit. So, okay, it lubricates it and maybe protects against corrosion, but you end up doing yourself a disservice by keeping any grit that's in there. If a piece of grit falls in, it's not going to fall out again if it sticks to the petroleum jelly, and will start to wear stuff away because it starts to act like a grinding paste. So yeah, it's a compromise, but I think it's, in this case especially, it's worth doing because it's quite a tightly enclosed space. So there shouldn't be much chance of grit getting into it anyway. This top part, I think, should just clip on rather. There seem to be these attachment points around the edge, and there's these sort of springy parts here. So these lugs on the outside should clip into those slots. Yeah. Great. Yeah, interesting. Interesting to see how it is arranged inside, and see how it's got those two springs. But I still don't understand why this bore seems to have reduced in diameter and caused that little piston arrangement to stick. Very strange. Anyway, hopefully that doesn't stick anymore. Yeah, I mean, that feels fine now. It returns smoothly. Good. So I'll find the key and so put this back in stock as a useful spare. Okay, thanks for watching.